Hello and welcome to Make 100 Games. This is the final video in my series about building a Mario Kart style kart racer in Unity. In the last video, we covered how to add some nice collectible coins to the game. This video will be a bit different. I will not be walking you through how to do something step by step like I did for the past 7 entries. Instead, I want to show you the performance issues that I encountered with the kart racer and how I went about resolving them. If you would like to learn about using the various performance tracing tools in a more step-by-step fashion, check out this video about optimizing a Unity game for Android. Anyway, let's jump in. So, quick bit of info, I have what I consider to be a criminally underpowered Android tablet lying around that I occasionally use to test the performance of my games. To be honest, I think even the native UI in the tablet just runs too poorly, so I don't really expect 60 frames per second for my game on there. Nevertheless, I like to run my games on it from time to time in order to learn about performance optimization. And if it can run on this tablet, it can probably run just about anywhere else. Anyway, so after wrapping up a solid version of my kart racer, it was time to run it on my underpowered Android tablet. And lo and behold, the game ran super slowly. Massive, consistent frame drops. The frame rate was basically locked in at an abysmal 15 frames per second. So I decided to launch Unity's profiler and have a look, and quickly saw that one of the biggest consumers of frame time was this wait for GFX bar. I had seen this in a previous game I built as well. Wait for GFX thread indicates that something running on the GPU is taking too long. In other words, our game has a GPU-bound bottleneck. So I opened Unity's frame debugger to see if I could learn more about what was causing this massive amount of GPU time. The frame debugger showed me a lot of really interesting information about how an individual frame of the game is rendered. I learned that my decals only take about 4 draw calls or so, which kind of makes sense. Pretty neat stuff, but not really what I was after here. The issue with the frame debugger is that it does not show any timing information. It gives me lots of information about what goes into rendering a frame, but does not tell me whether one or more of those steps took an unusually large amount of time. So it was time to bring out the big guns, the Android GPU Inspector. The Android GPU Inspector, or AGI, is Google's GPU profiler for Android. I've had success with it in the past, so I was hopeful this could help here as well. And lo and behold, AGI provided me with timing information about various steps of the frame drawing process. I quickly noticed that my render loop was very expensive, on the order of 100 milliseconds. I also saw that the game was issuing a massive number of draw element calls. Maybe that was the issue. Furthermore, my decals were also a bit of a time sink. At this point, I wasn't sure why the render loop was so expensive, but that large number of draw calls looked fishy to me. What you have to know is that at this point, I don't have a lot of game performance profiling experience, so my hunches are probably often just wrong. Anywho, I thought maybe I should try to find a way to reduce the draw calls, and maybe one way to do that was to use GPU instancing. So I went ahead and enabled GPU instancing on all of the spheres of my trees, the bars of the fences, and wherever else I was drawing identical objects. I rebuilt the app and saw that this had no noticeable effect. Even the number of draw calls did not change. Was GPU instancing even working? I later learned that GPU instancing does not really help all that much if you are GPU bound, like I was here. It helps more if you want to reduce the CPU overhead associated with issuing tons of draw calls for identical objects. But younger me at the time did not know this. But I digress. I then decided to remove the trees by disabling them because I thought that maybe it was the fact that the trees were not a single mesh that caused the issues. Just removing the trees made no noticeable difference. I then decided to also not draw the fences. Even without the fences, there was virtually no performance difference. The game still ran like a slideshow. These opaque objects still took way too long. The draw calls, on the other hand, were drastically reduced. So at least I now knew that the large number of draw calls was not the issue. Next, I decided to take out the decals because I saw that they also cost a lot of time. And as could be expected, performance did improve a bit. But the big elephant that was the 100 milliseconds of draw opaque objects was still in the room, and the frame rate was still suffering massively because of it. In AGI, I noticed that the Fragment shader utilization was at 100% for the opaque objects. As far as I understand, this basically means that all the time in rendering is basically spent in drawing the pixels to the screen as opposed to transforming vertices from world space to screen space, for instance. So the first thing I did was to reduce the resolution, because if we have less pixels to draw, then we should be spending less time drawing them to the screen. Reducing the resolution by 50% made a huge difference performance-wise. I decided to bring back all the trees and the fences and test it again, and the frame rate was still solid. Even AGI showed a massive improvement at this point. Drawing the opaque objects was down to 40 milliseconds. Still not great, but a 60 millisecond improvement. I guess it kind of makes sense if you think about it. When I changed the render scale from 1.0 to 0.5, I didn't cut the work by 50%. Cutting the resolution in half leaves us with just 25% of the original amount of pixels. That is a significant reduction in work to be done by the Fragment shader. At this point, I even brought back the decals, and even with the decals, the game was playable. Bringing decals back works because reducing the resolution will also make rendering the decals a lot faster. So by bringing down the resolution, you make each render step significantly cheaper. So much so that things that were too expensive before on their own, like the decals, are now within a frame budget that is almost acceptable. So reducing the resolution is definitely an approach to dealing with this performance issue. But it also confirms that the performance bottleneck was in drawing the pixels to the screen. And I can think of 3 potential causes for this bottleneck. The first cause can be that we just have too many pixels to draw. The second could be that the cost of drawing each pixel is too high. The third could be that we are coloring in each pixel multiple times. The latter is also known as overdraw. By reducing the resolution, we basically address the first of these causes. Now I wanted to take a crack at the other 2, or one of them at least. One thing I could think of was to disable the shadows. Drawing shadows usually involves looking up colors in a shadow map before drawing a pixel, which essentially increases the per pixel cost. So I put the render scale back to 1 to better isolate the effect of disabling the shadows. I then disabled the shadows and tried again. The result was definitely noticeable. I saw a visible improvement in frame rate. Still not great, but I was on the right track. The profiler now showed a duration of about 70 milliseconds for the wait for GFX bar in the flame graph. That is a good improvement from the initial 100 milliseconds. AGI also showed an improvement of about 20 milliseconds for the drawing of opaque objects. Another thing I thought about trying out was to change the material of my terrain from a lit material to an unlit material. Since we have a cartoony look, we don't really need any fancy lighting effects on the terrain. However, I was not able to change this so quickly as the base shader that I based my cartoony shader off of was a lit shader. So I instead turned the resolution back down by 50% and ran the game again. The profiler now showed the wait for GFX bar to take about 30 milliseconds. That's 70 milliseconds better than at the beginning. AGI showed that drawing the opaque objects now took about 30 milliseconds as opposed to the 100 milliseconds at the beginning. AGI also showed that the fragment utilization was down significantly, from 100% at the beginning to about 60%. So that was it. I managed to significantly improve the frame rate of the kart racer on my slow Android tablet. If I intended to ship this game for Android, I would likely invest more time in analyzing individual parts of the rendering process. As stated, I would try to use an unlit shader for the terrain, which would mean I would no longer be able to use the normal map on the terrain. But I could probably get a decent looking dirt road with a simple texture there as well. At the end of the day, I would probably still tone down the resolution a bit just to allow for more headroom. And if the pace of the game is fast enough, I think it would be hard for players playing on the tablet to really notice the difference. Alright, so that is it. This was the final video in the series on building a kart racer in the style of Mario Kart. I hope you enjoyed the series, and I hope you consider subscribing to the channel and liking the video. If you enjoyed this video, feel free to leave a comment. If you have some helpful performance tips or some interesting performance bugs that you had to hunt down, please sound off in the comments. Thanks for watching, and see you next time.